Hey everyone, we're going on to the last section in chapter 5, 5.4, which is on sampling distributions and the central limit theorem. So, what is a sampling distribution? So, it's a distribution of sample statistics formed by repeatedly taking a sample of size n from a population. Okay, so what we'll focus on is what's called the sampling distribution of sample means. Meaning, we're going to start with a population, and we're going to repeatedly take samples, and then we're going to calculate the mean of the sample. So like in this picture here, right? We have all of these different samples, and each one has its own little sample mean, x bar 1, x bar 2, x bar 3. What are some properties of the distribution of these sample means? That's what we're going to explore. There's a big central limit theorem that it's called that has some properties. So that first bullet point here, if a population is normally distributed, then the sampling distribution of sample means is also going to be normally distributed. So that'll be an important fact for the rest of the semester that we'll be using a lot. And then turns out is if your sample size is at least 30, like up here, if we just took 30 at a time and calculated the means, so as long as we have an at least 30 sample size, it doesn't matter what the population distribution is. Could be left skewed, right skewed, whatever. The sampling distribution is going to be normal. So that's pretty crazy, but that fact allows us to do a lot of things with hypothesis testing later. Okay. And there's even some formulas that will relate. So the mean of the sample means is just equal to the population mean. So this is the notation for it, mu sub x bar. That's the mean of the sample means. For example, in this picture up here, we have 5 sample means. If we take the mean of all of those means, it's going to be equal to the overall population mean, which maybe isn't too surprising. Seems reasonable. The standard deviation of the sample means is a little different. We have to divide by the square root of n, but that will be the standard deviation of the sample means. It's also called the standard error of the mean. Okay, so let's go on a little bit and then we'll do some examples. Finally, we can get a z-score. The z-score is our same formula, right? That's that sample. Well, I guess it's not this, it's same structure, I guess is what I mean. Before we had this, right, to find a z-score. We're still doing that, but now notice instead of an x, we have an x bar. Right? Instead of a mu, we have mu sub x bar, and then the standard error is in the denominator. And then if you replace with these formulas up here, it simplifies to this. So this will be our working formula to find z-scores for this section. Okay, so let's see how this relates to a problem that, why are we even doing this? Okay, first we'll practice just finding like mu sub x bar, sigma sub x bar. All right, so let's say the mean is 100, standard deviation 15. Let's find mu sub x bar. So mu sub x bar is super easy because the formula is just mu, and that is always given in the problem, so we're done. Sigma sub x bar, you got a little bit of work to do because it's sigma divided by the square root of n, right? So here we have 15 standard deviation. What is n? All right, well, it says 20 people. 20 people are selected at random. Right, and then so it's 15 divided by the square root of 20. You have to find that square root button on your calculator, but I think you probably won't have too much problems with that. And it says 4 decimal places, so this is, on my calculator, I'm getting 3.3541. Okay, so check with your calculator and make sure you're getting that value. Okay. What is the probability that the mean IQ of the sample of 20 people is greater than 110? All right, here's really the key to this section is these are the kinds of questions we're going to be asked. It's really similar to 5.2, but in 5.2 we would just have one person, right? What's the probability that one person has an IQ of greater than 110? Here we're ramping it up and we're going to say, okay, what if we randomly select 20 people from the population? What's the probability that their average IQ is greater than 110? Okay? And in order to do that, we're going to do that two-step method. But first we have to find the z-score. And we're going to use this formula that we just have on that previous page. All right. Now, what am I going to put for x bar? That's going to come from the question. So I'm going to put 110 there. The mean is 100, sigma 15, and then divided by a square root of 20. Okay, and I'm going to calculate this. I put parentheses around top and bottom because that's going to help me with my calculation. All right. So if I did bring up my calculator for this, just to show you how I would put it in there, all right, let's clear all this out. I would use parentheses. So parenthesis first, and then 110 minus 100. Right. Close the parenthesis, divided by, open parenthesis, 15, divided by, square root, which is I have to do second function x squared, get the square root, 20, close the parenthesis out. All right, so that's how I'd want to have it in my calculator, right, to get the correct answer. Okay, so this is about 2.98 for the z-score. Okay, so I'll go back here and get about 2.98. So definitely check with your calculator, making sure you're able to calculate these formulas. Okay, and then now what do I do with that? Okay, it's greater than 110. So I go back to StatCrunch now and find that value, right? So I go by my normal calculator, which we have here, right? And we want greater than, and then I put in, this is still from the last problem, I gotta have my mean 0, standard deviation 1, right? So that I have z-scores that way. And then I put in my z-score 2.98. We're back to putting in values next to the inequality, right? And then I compute it, okay? And I get 0.0014, all right? Which is a very small little area. You can barely see that little red area to the right, okay? And that's it. So then I go back to my handout and I do that. So for StatCrunch, it's just going to give me my final area, which is the probability, 0.0014, all right? And that's all we're going to do, okay? So it's really quite similar to 5.2. So these feel a lot like them, just it's that one thing where we're taking no longer just one person, but a group of people, right? And this makes sense, like, you know, if the average is 100, if you got 20 people together and their average was greater than 110, that would be pretty rare. So that's why this percentage is so low. It's just a rare occurrence. How about another one? What is the probability that the mean IQ of the sample of 20 people is between two values? Okay. Let's get the z-score, and then eventually I can show you a StatCrunch shortcut, but I do want to practice with this formula a little more. Right? So now I have x bar of 95, right, minus 100 divided by 15 divided by square root of 20, right? That's all the same. So I'm just calculating that 95, which in my calculator, I'm getting negative 1.49. So again, you might want to verify that your calculator is giving you that. Use those parentheses. Hopefully that works out. Okay. The other one, I have to get two z-scores on this one because it's between two. I gotta do the 105 minus 100. Now you might notice this is about the same thing. It's just the top number instead of a -5 is a +5. So this is actually positive 1.49 if you calculate that. Okay. Okay, so I turn my sample means into a z, and now, or z's in this case, now turn those into an area for the final answer. It's between those two, so I go back to StatCrunch. I gotta go up to my between option, and then I put in those two values. Negative 1.49, 1.49, compute. And I get my overall area, 0.8638. Okay, so that looks good. And that's my final answer, right? It's the probability of being between those two. Okay. Okay, continue. Now we just have some extra practice here, but I think we've pretty much got this down. There's nothing new. This is just going to be practice and maybe some StatCrunch shortcuts. Okay, so here, corporation, we got a mean, all right. We got standard deviation, credit card, debt. All right, what's the probability that A randomly selected? So here is just one, right? A randomly selected, one student. That's just a 5.2 question then, right? So if you want to do this all at once in your calculator, you could, I mean in your StatCrunch, right? You can just go to our calculator. I gotta do, in this one, we're doing the probability of less than 2,700. So I'm gonna go standard. I gotta do less than. I can put in my mean is 3,173. Standard deviation 1,120. And then less than 2,700. Doing it this way, if you put in the mean and the standard deviation, you bypass finding any z-scores, and you just get the answer straight away. So 0.3364. Okay, so that was a little 5.2 review. Now so the point of A and B is now compare that. Now the second one, now you select 25 undergraduates, right? So that changes your standard deviation in StatCrunch. But if I go to StatCrunch now, how do I account for that? Instead of 1,120, I gotta divide that by square root of 25. So actually what I would want to do is go into my calculator. I can't really do it right there. Let's go to the calculator and do that division. So 1,120 divided by square root 25 is 224. So that's what I'm going to put for my new standard deviation into StatCrunch. So just put in 224, and then less than 2,700 is still the question. Compute, and I get 0.0174. All right, okay. So notice what the big difference is from 5.4 is you got to account for that more than one person by dividing that standard deviation by the square root of n. And then it still works out the same. So 0.0174, final answer. Now let's compare those probabilities, right? If you have just one person, probability that their credit card debt is less than 2,700 is about 33%. But if you have a collection of 25 people, the average of all those 25 students less than 2,700 is pretty low. It's only like 2%, right? So that seems to be reasonable. Okay, let's try one more, and then this will be the end of the section. So the average math score is 524, so we have a mu of 524. Standard deviation 111. Particular high school claims that their students have unusually high SAT scores. So let's test that. A random sample of 40 students from the school was selected, and their mean was 571. That's an X bar. So X bar 571 and an N of 40. Right? Is that unusual? So to test if it's unusual, I would just find the Z. Right? So the Z-score, we're doing X bar minus mu divided by sigma divided by square root of n. So I'm going to do 571 minus 524 divided by 111 divided by square root 40. Right? And then again, you can practice putting that into your calculator. Right? But when I do it, I'm getting 2.68. Okay, and that's a z-score that's larger than 2. So remember our rule for z-scores, if anything's larger than 2 or less than -2, we're calling that unusual. So yes, this group of 40 students is unusual. They would have unusually high SAT scores because their sample mean is more than 2 standard deviations above the mean. Okay, so that's that. Okay, I hope that makes some sense. Give 5.4 a try. If you have any questions, let me know. Otherwise, I hope all is well, and I'll talk to you next time. Thanks. Bye.